So in the last while, when I planned this circle geometry course, I planned it in a way that there are three major sections. There is circles and the center, which was the first two lessons. We then have circles and cyclic quads, which is kind of what the week we're in now. And then next week will be circles and tangents. Now, what I aim to do in these sessions is to make you familiar with the facts or the theorems that relate to these different subsections, right? So what are some of the theorems that go with this content knowledge? And we often use those facts or those theorems to help solve problems of like what is this angle equal to, together with reasons. Now, as you get better at circle geometry, you can then advance onto something called the converse theorems. And the converse theorems, I'll just say converse theorems, deal with how do you prove something is a tangent? How do you prove something is a cyclic quad? How do you prove that something is a diameter? Which, in my experience, is not actually that hard, but you do need to build a solid knowledge first. And then there's also the topic of proofs, which I will release later on in this course. But for now, I found that it's good to build up some knowledge of this. Now, when you use these facts or theorems, you do need to be aware of reasons. And so I just want to have a quick look down memory lane of some of the facts and theorems you should be aware of. So Pythagoras, that's something you should know about. Radii in a circle, so that they make isosceles triangles. This is an important idea. We covered this quite recently, that a line from the center perpendicular to the chord, it cuts that chord in half. There's also the theorem that says line from the center to the midpoint of a chord, so that's this one, it has to meet at 90 degrees. I'm going to leave this one out for now. It's not as common. Then we did the angle at the center is twice the angle at the circumference. So we've dealt with that. And then a real focus tonight is going to be on this one, which is angles in the same segment. And that often they call it the butterfly theorem, and I'll talk more about that later on. This is a converse theorem, which we'll talk about in another space. This is angles in a semicircle. So if you've got a diameter, it makes an angle of 90. So that was week one. That's another converse theorem, which helps us prove something. We did speak about that equal chords subtend equal angles. So that's related to angles in the same segment. And then on Monday, we dealt with opposite angles of a cyclic quad, that they add up to 180. And we also dealt with exterior angle of a cyclic quad is equal to the interior opposite. And we used that reason. So I just want you to give me a score out of 10 of how well you understand those facts that I've just kind of run through very quickly. 10 is perfect understanding. 0 is no understanding. 5 is like sort of in the middle. How well do you feel like you understand the facts that I've highlighted on the screen? Now, I'm going to put this summary of reasons in our Google Classroom, so don't worry if you like scrambling to get it down. It will be something that I will make available, but it's just about building up on knowledge. And as you build up the knowledge of the pictures, the section becomes easy, but you've got to do the hard work. You've got to do the base training. Okay, so let's look at the main fact for tonight, which is the angles in the same segment, or angles on the same arc is sometimes how it's called. Both are acceptable reasons, but I think the quicker one to say is angles in the same segment. And let me try and give you a little visual interpretation. So at the bottom is a red arc. You could join the 2 points and make a chord, not a problem. We call that the base on which we subtend angles. We subtend the angle up here as 48, and the one up here is also 48, and they start from the same base. But look what happens, ladies and gentlemen. If I move this out, it doesn't really matter as long as the angle being subtended on the circumference is at the circumference and it's got the same base, it stays the same. Now watch what happens if I change the arc length. Now, you'll notice that the angles still have this lovely relationship where they're equal, but they have changed in size. Let me change this out here. Okay. Now, what you notice is, even though it's a bit counterintuitive, if this is the base and then you subtend that angle there and you subtend that angle, those two angles are equal. And we call that angles in the same arc or angles in the same segment. The reason it's called angles in the same segment is basically this part is one segment and that part on the other side is another. Okay, so that's to introduce the theorem. And sometimes if you look in textbooks, they will, they'll basically give this reason: angles in same seg, and you can put a dot on the seg and it's nice and quick. And you can see that these two are equal. Now, if you had to flip this around, so if you had to focus on the arc CD, you could also see that angle B will actually equal to angle A. And it's just kind of gone backwards. So it's kind of like if you start at CD and you subtend an angle at B, and you also subtend an angle at A. Sorry, that's a bit of a messy picture, but basically these two angles over here would be equal. Okay, so very simple question, just to check you've got the idea. What is angle X going to be? What is angle X going to be? I mean, come on. I mean, I suppose, guys, I'm sorry. I just had to check that we got that. So we go X is 40 angles in same segment. Okay, so we're off to the races. We know that this angle is equal to this. If you want to see, sometimes I say, what is the arc that is doing the building? The arc is down there. And you can see it subtends that angle at the circumference and it subtends that angle over there. And that's why they are friends. Turns out this one down here would also be equal to this one. Just bear that in mind. Okay. I think the one on the left is too easy for you guys, so we're leaving that out. But I want you to try and find me X and Y for this. And notice there's something a little special here. What do those two arrows mean? What do those two arrows mean? They are parallel lines. Indeed, Sange. Indeed. Silikani, the same thing. Tsapang, you guys are on this like. Okay, Simtanda, you guys are all correct. Now, what relationship would be helpful to find X a value? Because the theorem I was just talking about says, okay, well, this angle is equal to this, but that doesn't help me. So what relationship is there between this and this, if those are parallel lines? Yes, use fun or use alternate angles. So X is 50, alternate, let me just do the reason below. Alternate angles. And if you had parallel lines, you would say like AD parallel to BC or whatever the thing is. Okay, so now we know that X is 50. What is Y going to be? I'll give you a little hint. I'll give you a nice arc to guide you. So, yep, this angle Y can be made from that arc here, but so can this. And so these two must be friends. And Y is 50 by angles in same segment. So that's 50 as well. For bonus points, what is the size of the angle with the green dot going to be? What is the angle with this? Okay, and the reason it's, and I'm sure you all know this, is the reason it's going to be 80 is there is a triangle there. So sum of angles in a triangle. Awesome. Okay. We can move on to something a little bit more exciting, I think. So we are going to do the next 3 questions over here. I'm going to give you some time by yourself, some quality time. You are going to find me B and A. You are going to find me C and D. And once you're done with 1 and 2, say done, and then we'll go on to 3 together. So just say 1 done when you're done with A and B, and say 2 done when you're done with D and C. Okay, over to you guys. I'll come back in a second. So we are going to say that A is 27 degrees because this is the arc that is going to be the base, and that's the one angle, and then there's the other. So we'll say angles in same segment. And then for B, I think that that would be the dominant. So this angle over here would be equal to that angle over there. And so we know that there's a 30 here, so this B must be 30. So B is 30, and this would be angles in same segment. So that's 30, and this was 27. Okay, let's do 2. 2 is a little bit harder. Where am I looking to start with? I feel like my hint to you would be to start with this arc over here. And that could help you get C. So if that goes to there, then this must go up to here, and C must be 20. I'm just going to say this, but it's the same reason. So that is, C was 20. What's D going to be? Oh, it's kind of giveaway now, I guess. Because this arc over here would be the base from which we're starting. And then this could be D, and this could be the same as D. So D must be 45, and that is angles in the same segment. Okay, I think we're all okay. If not, please do stay slow down or chat, tell me in the chat. But now I want to move our attention to finding what C is, what E is, and what D is. And there might be a bit more going on here. I have to keep track of what's going on here. I'd love a question if you're unsure, but otherwise I'm going to trust that you are giving it a go. And until I hear a question, I'm just going to let you go for it. And then if you could just pop your answers in the chat as you get the answers for C, D, and E. I feel like we're doing our pre-season training for circle geometry, building those muscles. Oh, my screen just decided to change to nighttime. Let's change it back. There we go. Let me know in the chat if you're done with 3 or if you've got a value for C and E and D. I'll start giving some hints now. Where would I start? I think I would start by looking at this arc over here. And then this would help me find C, because I think that this angle over here goes with this one here. So C is 58 degrees. And again, it's the same reason as above. I'm not going to keep writing it, but that is, you should, if this was, but you'd never get asked this many questions in an exam for the same thing. So C is 58. Now, what is D going to be? Let's have a look. So I've got, that is 58. Where would I go next? I think I would go after E. So I've got this arc here, and I am saying I could subtend that angle, but I could also subtend this angle. And so then E must be 30 degrees, angles in the same segment. So that is 30. So I've got that, I've got that. Now, how do I get D? Oh, I can see D must be 41, because I'm going to choose this as my chord that I base it on. And then D can also can subtend this angle 41. And so D is 41 degrees. Okay, everyone, give me a score out of 10, how you felt about these 3 questions. The numbers you tell me help me decide what difficulty question I should do next. So 0 is no understanding, 10 is perfect, 5 is sort of, 8 is like a pretty good understanding, but I'm not doing this blindfolded or whatever. Okay. Let's do number 4. I'm not going to escalate too much yet, but I definitely sense that you guys can take some more difficult questions. But let's try and do number 4, because it is a bit different, because there's no parallel lines. So find me F, G, and H. F, G, and H. Okay, so here is my arc. I'm being a bit lazy. I'm not using 2 colors. So F is 40, and then there'll be angles in the same segment. How am I going to find G? It feels like with G, I need a different idea. I think that you've all noticed that this is a triangle, and sum of angles in a triangle, yes. So 180 minus 40 minus 85, and that should give us, can someone help me here? Where's my brain? 55. I get 55. 55, hold on. 95, yes, I'm right. And then H must also be 55. Let's see if I can show you why that is. You know that that arc builds that one. And so there's that angle. And there is that angle. So G and H are buddies. And this would just be angles in same segment. Okay, so I definitely think we can go to more detailed questions because we've got a nice solid base. Are there any questions or comments before I move on? Any questions or comments before I move on? Okay, then let us go to question 5. Let's see if you can do question 5. We'll do question 6 in a moment too, but well, we've got 4 minutes until our break, so let's try and do 5 and 6, and then we'll take a break. Can I zoom out a bit? Is it a bit too big? Is that better, Silicani? Perfect. That is what I like about doing this live. You can always send in your requests. So we have to still get C in this one over here. And so we need to think about how to do that. Any ideas for that? What should we do to get this one over here? Well, I think I just realized it's a triangle. So there's a bit too much detail on the screen. But if we take some of that detail away, then we can see that this is a triangle. And so then C is just going to be 180. So 180 minus the 80, and also minus the 32, and minus the 25. And so that is just going to be sum of angles in a triangle. I'm going to leave that reason blank for now, but just say sum of reasons in a triangle, sum of angles in a triangle. What do you get for C? Just pop it in the chat. Yeah, 43. Anyone else? Yep, there we go. Fantastic. Okay, so we've got 43 for that. And then let's just do question 6, and then we're going to take a break. So can you find me X? Can you find me Z? Can you find me Y? And where would you start? Which one is the easiest to get first? So those two are equal y. So this x and y feel like they are going to be the same. But the problem we have is we don't know what x or y are. But I've had an idea. What is this green dot going to be? Do we know what that green dot's going to be? It's 96, yes. And so if that green dot is 96, okay, so green dot is 96, the reason is vertically opposite angles. But now I can know what y is because it's 180 minus 50 minus 96, sum of angles in a triangle. And so y will be equal to 106, 146, 34. Steve and I agree. Now, if I know what y is, what is x going to be? What is x going to be? Yep, you guessed it. It's 34 degrees, and that is angles in same segment. Okay, now the only one we haven't got yet is Z. Can someone help me find Z? It's hanging out up here. Now, unfortunately, its sort of partner in crime would be here, but we don't have it. But maybe we can get it another way. Ooh, I remember something about straight lines that I think could help me here. So I think the black dot must be 180 minus 96, which is 84 degrees. Angles on straight line. And then if that is 84, I feel like someone can help me get the red dot. What is the red dot going to be? So the red dot is going to have to be 180 minus 84 minus 40, and that would just be sum of angles in a triangle. And the value would be, thank you, really, I agree with you, you get 56. So this one is 56. Now, what is Z going to be? What is Z going to be? So the good news is now this is just angles in the same segment. So Z is 56 angles in same segment. And that is half time for us. I think we've done a lot. And so it is essential that we take a moment to take care of our brains and that we just get some oxygen, some blood flow, and some relaxation. So turn your cameras on. I want to see your lovely faces, students. I want to feel connected, like we're a team, like we're driving on the bus together. And I want you to just stand up with me, just stretch out, just loosen up a little bit, maybe just roll your shoulders back. So if you've been focusing a lot, if your brain's been working hard, you need to tell it, look, just take 2 minutes to unwind. It will pay off in the long run in terms of your learning. So we're just gonna roll our shoulders back a little bit. And then we're gonna roll them forward. And then we're gonna just shake our arms like we're in a drama class or something. We're just loosening up. I used to teach next door to a drama class last year, and I used to sound like they're having so much fun. And I was like, why can't the maths department also do this? So now we do relaxing between double lessons. We do a little, little shake and bake. Okay, then let's do 2 or 3 deep breaths. So breathe in. Nice deep breath out. Breathe in. One more. Breathe in. Okay, then let's just do, so arms out to the sides. Let's just rotate very gradually. And as our hips loosen up, we will feel like I'm going further. Okay, and then let's do some tricep stretch. So behind like this, head in front, tricep. Hopefully your shoulders get a nice stretch. Oh, I can feel mine a bit tight. Up like this, and loosen up again. Okay, so we've relaxed a little bit. We've got some oxygen. Last thing, just some blood flow pumping. We are going to do 15 jumping jacks. 1, 2, 3, 6, 7. And there we go. We have finished our warm-up or our mid-lesson break. And so I say to a lot of students last year, I remember telling them, look, tell your teacher that if you have a double lesson at school, I don't know if you have double lessons, but honestly, it's a game changer. If you have these breaks between your double lessons, it just helps reset your concentration. Okay, a little bit of fun. Here's like one of these puzzles that you see on the internet. What is a hamburger plus a packet of chips times a McDonald's shake? What do we have coming in? So a shake is indeed 10. You can kind of see mathematically, this is sort of like saying like 3m equals 30. I mean, obviously, you know that. So that is a 10. And then this must be 5. You are quite correct. Now, because there are 2 packs of these, there's going to be 1, 1, 1, 1 there. What is the final thing going to be? So it's 5 plus 1 times 10. Now remember, BODMAS has to come into play. So what is that going to be? Because remember, each one of these fries is 1, because there's 1 there. So it's 5 plus 1 times 10. So indeed, you guys have smashed it. It is going to be 15. Okay, so I hope that your brain is feeling a little bit relaxed. I know my brain is. I I suspect yours is too. So let's do number 7 together. So in number 7, they don't give any parallel lines, but what they do give are these 2 things. Now, what do they mean? And then they say you have to find what T is up here. So see if you can do that. Yeah. Okay, what do we get? So I think the very first step should be to work out what these angles over here are. So I'm going to call them X. Find me the size of angle X first. So I'll let you put that in the chat. What is the size of angle X? And then from there we can go. Okay. So if I realize that this is 94, I think I can just say that 2x plus 94 equals 180. And the reason for that is just going to be the sum of angles in a triangle. And then what is x going to be following from? Well, actually, there's going to be two reasons. So let me write them both down. So you've used that the sum of, let me not make it two. Sum of angles in triangle. And you've also used the fact that you've got two sides equal in a triangle. So you've given that. So what is my x going to be? So x is indeed going to be 43. So this is 43 and this is 43. Now what is t going to be? The thing in yellow that we were after. So because this arc or this chord is the base, this angle here and this angle here, x will be, t will be 43 degrees. Yeah, Simtanda, let's go to you. What is your question?
So sir, basically I was asking if the angle 94 here, the angle 94
Yes,
does it come for the whole thing for
yes.
whole piece?
I think, yeah, it does. So that's, you can see this. I know it's maybe a little bit unclear, especially on your screen, but it covers this whole thing here. Does that
Oh,
help?
okay. Yes, sir.
Perfect. Thanks for the
Thank you.
question. Okay, so we know that T is 43 degrees. Okay, well, let's go and look at another type of question. We're making good progress here. Let us quickly look at these two questions. So let's make this a bit bigger. Hopefully you can see it. I'll make it even bigger than that. So can you find me, it says in the following diagrams, O is the center of the circle, but the first one has no center, but the second one does. Determine with reasons the value of X and Y. So they say, what is X here? What is Y here? And in this one, what is X here? And what is Y there? So I want you to put that in the chat and you can tell me what you are getting there. Okay. I'll give you a little hint. Which arc would I use? I think I would use the arc CD to help me find what y is. I think y should be 20. And that will just be so if that's 20, actually, this first one is quite easy. X is 35. Second one's a bit harder. Which one should we do first, X or Y? I'm having a few things remembering in my head about if you have a diameter, there's a theorem that deals with if you have a diameter and you make an angle at the circumference, what do we know about that whole angle? That whole angle actually has to be 90. So the way I would write that would be ACB is 90, and the reason given would be angle in semicircle. But because you know that one is 20, then X must be 70. So we know that X would be 70. Now, what we don't know is what Y is going to be. So does anybody have any ideas or suggestions about Y? Oh, I recognize something. Maybe you have two. What is special about these two lines? What is special about those two green lines? They are radii, yes. And what do radii make? They make isosceles triangles. So you can say y is 20. You can either say radii, or you can say angles opposite equal sides. So literally, those two sides are equal. The angles opposite them must also be equal. Okay, so we've done a lot of practice getting to know the shapes tonight. Let's go and look for something a bit more tasty. Let us look. Ooh, I like the look of this one. This looks a bit more combination. So if we look at this one, you're not just going to be using angles in the same segment. There are other theorems that come to mind. It's a lovely question. Okay, I want us to do this as a team. So the only angle that we've got is 137. Which would be the first angle you would find out of the ones that we need to get, which are Z, X, Y, and W? Which one would you go for first? Tell me in the chat which one, and tell me if you think you know what angle. Angle X. Yep, you could go for angle X. I was thinking angle W, but I mean, there's not really a wrong or right way to do this. The reason I was going to go for W, but again, X is actually probably the better choice now that I think about it, is this is a cyclic quad, and I've still got cyclic quads on the brain. So what would, humor me, what would W have to be? What do you think W would have to be? I think there's a relationship between the W and the yellow bit there. And I think these are opposite angles in a cyclic quad. And so what we would do is W would be 180 minus 137. And the reason would be opposite angles cyclic quad. And then W must be 43 degrees. Now, I'll let you choose what you want to do, but I want to see some answers in the chat for X, Y, Z, etc. Or maybe somebody can come online and just tell me what they got. Up to you. I like this question because it's using a couple of different theorems that we've spoken about, or a couple of different facts. So I think the next one I would go for, we don't have to, is I would go for y. And I would say I can see the arrowhead here. So y is 2 times 43, which is 86. And that would be angle at center is twice angle at circumference. And then once I know that, I would say x is 360 minus 86, and that would just be a revolution or angles in a revolution. And that would be 26 minus from 300, so 274. And then what would z be? And I've just thought that for z, maybe I could just join r and s, use that as a base, and make this angle up here. So what does that force z to be? What does that force z to be? So I think that it forces z, because it's actually the butterfly shape. And you can see the 4 points. Now remember, for the butterfly shape to be valid, you have to have a cyclic quad. But I see it. I see a cyclic quad. Z is 43, and that is angles in same segment. Okay, give me a thumbs up if you've got one more question in you. Give me a thumbs down if you're like, okay, I'm ready to wrap this up. Give me the quiz link. You can let me know in the chat. Siamtanda, what is your question?
So sir, what if we said Z is 43 in another way with a different reason?
Would you say that again? What if you got Z is
What if I
43 in
got
another way?
with a different reason, like the angle at the center is
Yes, perfect. I've just seen that now. So you saw that y was the angle at the center and z was the angle at the circumference, and so it would just be 43. So
yes.
you absolutely perfect. Couldn't have, yeah, completely fine.
Thank you, sir.
Okay, really, is there a question, or is that just to say one more question for tonight before we wrap this up?
So I'm asking for Z because I used the line in the segment. Problem is you said that Z is 43. With the line
Yes.
in the segment, I got 86. Are all the points meant to be on the circumference for me to use line in the
Yes.
segment?
This is such an important thing. Thank you so much for raising this. Okay. It's very tempting to think that this is a butterfly, but it's not the butterfly shape. The reason is this point is not on the circumference. So what this actually is this is an example of the angle at the center. So if you imagine this arc here, and now you're going to build an angle at the center, and then the angle at the circumference is going to be half that size. And they can get confusing sometimes. But can you see the difference? Whereas that's angle at the center and the other one, whereas if I look at this, these 4 points are all on the circumference. Okay. Rulias, your hand is up. Go for it. Or is that, does that answer your question? Okay,
Yes, sir, thank you.
perfect. Okay. Oh, perfect, perfect, perfect. We've done that one already. Let's end with this one. Can you find me the size of angle X? Can you find me the size of angle X, which is sitting up here, and you've only got this 82, but you do have some friendly arrows that can maybe help you on your journey. But I was thinking I can probably get that one. And I can maybe get that one. And maybe I could even get that one. Okay, so we get what do we get for x in the end? Is x quite small? It looks like, no, that can't be right. Have I made a mess up? So I got 82 for that. I got that. I think I must have made a mess up somewhere. This is 180 minus 82. No, that's 98. So if that's 98, oh, I know where I made a mistake. Okay. Look at me. I think I'm getting to the end of my energy for the day. So I now need to get BDC is not 98. BDC, so BDE is 98. That's fine. But BDC should be 180 minus 98, which is going to be 82. Oh, and now I'm happier. So X is going to be 180 minus 82 minus 82, which is 164, which gives me 16. And that last reason was sum of angles in a triangle. Okay, everyone. You have done very nicely today. We've made good progress. And next week, we're going to move into tangents and then maybe some other types of questions as well.